we arrive to the steps of synaptic functioning. We take the example of a neuronal synapse. Here the synapse is at rest. The vesicles are still in the presynaptic neuron. There is no neurotransmitters released in the synaptic cleft, and the chemodependent channels and the voltage dependent channels are closed. Now, the first step of synaptic functioning is the arrival of an action potential, as you can see here, to the presynaptic terminal bud. This action potential is created due to a depolarization of the presynaptic membrane. And this depolarization, this action potential, allows the opening of the Ca2 plus voltage dependent channels and the entry of Ca2 plus into the presynaptic membrane. So this is the first step in a synapse, the arrival of an action potential to the presynaptic terminal bud and the opening of Ca2 plus voltage dependent channels to allow the entry of Ca2 plus into the presynaptic membrane. Now, the Ca2 plus allows the migration of synaptic vesicles and the fusion of the synaptic vesicles with the presynaptic membrane. This is the exocytosis, the fusion of the synaptic vesicles with the plasmic membrane is called exocytosis, and the exocytosis leads to the release of neurotransmitters in the synaptic cleft. So the importance of Ca2 plus ions is that they allow the exocytosis, they stimulate the exocytosis of synaptic vesicles and the release of neurotransmitters in the synaptic cleft. So this is the second step, release of neurotransmitters in the synaptic cleft by exocytosis. The third step will be the binding of neurotransmitters, here in green, to their postsynaptic receptors, which are coupled to ionic channels. In fact, it's the spatial configuration of neurotransmitter that allows its binding to its receptor. The neurotransmitter is like a key. If its shape is right for the neuron, here the lock, then it will produce an effect in it. So we have a complementarity in the spatial configuration between the neurotransmitter and its specific postsynaptic receptor. After binding of neurotransmitters on their postsynaptic receptors, we have opening of the chemodependent ionic channels. So the binding of the neurotransmitters to their receptors allows the opening of the coupled chemodependent ionic channels and the inflow or the outflow of ions. The nature of the ion that will move across this channel depends on the type of the synapse, whether it is excitatory or inhibitory. We will explain that later. But note that the neurotransmitter acts only at the postsynaptic membrane receptors and never crosses the membrane of the postsynaptic neuron. It's not the neurotransmitter that will enter through the channel into the postsynaptic membrane. The neurotransmitter remains on its receptor. We have ions, K plus ions or Cl minus or Na plus ions that will move through the channels, and they will either enter the postsynaptic cell or they will exit the postsynaptic cell. So the neurotransmitter does not enter the postsynaptic cell. Now, following the opening of the chemodependent ionic channels, we have perturbation in the membrane potential of the postsynaptic cell, and we have generation of a postsynaptic potential following the entry or the exit of ions through these channels. And this PSP, postsynaptic potential, will be transformed into an action potential if the synapse is excitatory, and thus the message will be transmitted, or the PSP remains inhibitory and inhibits the transmission of the message if the synapse is inhibitory. Also, we will explain that later. After the passage of ions through the membrane, and after their action, neurotransmitters are eliminated from the synaptic cleft. It's the last step in the synaptic transmission. The neurotransmitters are eliminated by one of the following mechanisms. They are degraded by specific enzymes present in the synaptic cleft, or they can be recaptured or recycled by the presynaptic terminal bud to be used in the next synapse, or they can simply diffuse out of the synaptic cleft. So, after their action, neurotransmitters should not remain in the synaptic cleft. They should be eliminated either by degradation with specific enzymes or by the recapture by the presynaptic terminal bud or by simple diffusion out of the synaptic cleft. You have to study and memorize the steps of the synapse. Thank you.